Hello YouTubers, this is Scribe and thank you for watching this YouTube video. So remember a few weeks ago I was talking about the Titan submarine and how a lot of people online had got a lot of stuff wrong, right? Including scientists, so-called scientists who are actually more into films rather than actually, this James Cameron didn't build his own submarine, put it that way. He paid somebody because he's a billionaire, so he can, drive a little submarine and claim to be a scientist. Well, here's the thing, right? I want to talk about three components of this science involving what would happen in the Titan submarine and clear some air, because I think a lot of things have been wrong in the community of YouTube, and many people haven't even fixed the problem that's there. They just come up with some guesses, whatever sounds good. You find yourself at the bottom of the ocean, you'll be crushed like a postal stamp in a second. No, you won't. Right? Things like that. It all depends on how fast or how slow you got down there. So if you teleported there, you blow up like an egg. Right? However, you go down slowly over many hours, you drowned and you find yourself at the bottom of the ocean, like where the Titanic is. You don't get crushed, and there's a reason for that, and we'll get into it. So the first thing I want to mention is the temperature inside the submarine. Many of them online have claimed it would have been twice the surface temperature of the sun. Okay, and they were claiming it would atomize a human body within an instant. Sounds wonderful though. It sounds like a Disney movie that James Cameron would make, like a little bit of magic. Goodbye you. That's kind of what you get my point. It disintegrates rather than just gets crushed like splattered like an egg. I mean, the human body wouldn't get atomized in the way you think. It just wouldn't happen. So what actually happened here? Well, let's talk about the heat. So they were talking about twice the temperature of the sun, right? I'm going to call bullshit on this, right? And I'll tell you why. Even if the temperature of the sun got twice the surface temperature of the sun, even if the temperature inside the Titan got twice the surface temperature of the sun, it would not disintegrate a human body or atomize it at all. Right? It might burn them, but it wouldn't atomize them, and plus the fact the water outside would quickly eliminate it all. Right? So it wouldn't be enough to destroy and atomize a human body at all. There will still be a lot of components left in the human body, including skin, hair, everything. Right? Maybe slightly burnt. That's it. However, they were claiming, a lot of them, including people like James Cameron, that they would have been disintegrated within an instant due to the temperature. Alright, let's get into that. Okay, the heat inside the Titan was enough to atomize a human body within an instant and leave no trace. Right. Okay, I want to ask James Cameron one question, and the scientists have claimed this one question. What's the melting point of titanium, and what's its heat conductivity? Okay, that's the question. And then I'm going to say the melting point of titanium is lower than the melting point of human bone, and it has a higher heat conductivity by 1,000-fold than a human bone. Right? So there's enough to completely atomize the human body, including the bone. There shouldn't be any titanium left at all. Right? Because it's disintegrated something with it's 1,000 times less heat conductive and has a higher melting point than itself, right? So titanium shouldn't last in that situation. Also, carbon fiber itself is over 1,000 times more heat conductive than the human bone, and it does have a much higher melting point, but it's nowhere near the surface temperature of the sun, and it's nowhere near twice the surface temperature of the sun. So this thing should have been completely mangled and melted and just broken down completely, and that's not what happened. They found full parts. And they also found human remains, which they're doing DNA tests now, so obviously that's not happened. The magical thinking of these scientists hasn't happened now. Would they get crushed now? Well, a fraction of a second, a millisecond being crushed, that's not good. Especially with all that water. You've got to remember the cubic meter of water is the metric ton. Right? And they're thousands upon thousands of meters down, so they're 3,000 meters of water above them, pressing down on them. That's got to do some damage. Another thing is when they were talking about the pressure. Now this is something that's very, very interesting. We'll get into this. Let's say somebody was sitting near the window, right? What looks like happened is the window gave in, but let's say that the whole outer layer was blowing out within a fraction of a second, allowing the people to be sucked out into the ocean. What would happen then? This is going to get interesting. They would get splattered like eggs in a second, and I'll tell you why. The air inside the nostrils, inside the body, inside the throat, inside the lungs, and the body itself does get compressed, right, within an instant. And it gets compressed because it hasn't had time to equalise the pressure outside. The problem is the air inside your lungs get compressed within a millisecond, right? So you go pop. The air inside your nose and nostrils and mouth gets compressed, and that here gets compressed within an instant. Pop. And it's faster than a speeding bullet. It's faster than a shotgun, right? So you've got millions of thousands of tons of pressure hitting you within a millisecond faster than a shotgun. So your head just blows up and you just get splattered basically. You don't get imploded, you get splattered. Also, because you're getting compressed by 5%. Now this is something I didn't really want to get too far into because yes, water can be compressed by water. Okay, it wasn't quite true what I was saying before, but it's 5% at that depth. Like 5% isn't a lot. It is when it's in a millisecond, right? Because for instance, I'm 6'2". I weigh 6'2", and I'm about 187 centimeters tall, right? I would lose, let's say, 5% of that within a second. So I'm at about 7 centimeters within a second, right? Down, right? Within a millisecond. That's faster than a shotgun, so I get splattered. Right? I break apart completely. That's all that would happen. It would be more like a balloon getting popped at that depth. Alright. However, here's the kicker, and here's the funny one. If I should somehow drop down to the bottom of the ocean by starting from the top, whether that's drowning, which I don't want to do, or let's say they use some kind of NASA water oxygen into the lungs and nostrils and everything, so I can actually breathe underwater, and I get dropped slowly. Now things begin to get a lot more interesting. I do get compressed, but I get compressed slowly, and everything equalizes itself out. Now there is a problem here. You have to be let down very, very slowly, because one thing, the bone compresses differently than fluid. Right? So the bone is slower compressing, and the problem with that is the skull. Right? So the first thing that's going to get compressed is all the liquids and all that they can handle that. What can't handle it as well is the bone, because the bone's got to get compressed by 5%. Now it is fluid, it is able to be compressed, but it has to be done very, very slowly, much slower. So if you go down too quickly, you break bones, you break your skull, things get cracked. Now one thing that's different with sharks and things that go to the bottom of the ocean is their skulls have got gaps in between them so they can be compressed. Stuff like that happens. Very interesting stuff. So yeah, you do get compressed, but if you're getting compressed slowly, you don't get that shotgun effect. That's so very, very dangerous for a body underwater that gets teleported under, right? And this means you potentially could just drop down to the bottom of the marina trench and not get crushed at all. You would lose, I would lose like 10 centimeters in height, but I wouldn't get crushed. However, there are other problems. Right? We're not meant to live down there, and because of the pressure, right, the gases inside our blood get compressed too. And you need some kind of genetic engineering to deal with the nitrogen inside your blood that's now building up. And the human body doesn't have those genes that sharks have and other little creatures down at the bottom. They don't breathe in the same way we do. They use a different system entirely, and that's something that many people didn't really understand. So yeah, you do compress, and water does compress, but not to the same extent as many people will think. You don't get crushed to the size of a postal stamp. Now, the most interesting thing of all, right? Everything gets compressed, right? Atoms cannot get destroyed, right? When people say that atomizers, no, atoms cannot get destroyed. They don't get destroyed. They get dispersed, right? They move all over the place, right? So if you get squished in water or the submarine, the atoms don't get destroyed. There's not enough pressure down at the bottom of the ocean to destroy atoms. There's not even enough pressure in the sun to destroy atoms. And I'll go even further. There's not even enough pressure in a black hole to destroy atoms. What happens is the pressure crushes space. Crush space. Crush space. Right? So, for instance, the pressure under the water on the surface of a very small planet, right, is enough to collapse water by about 5%, right? It's nothing, right? But as you go into deeper and deeper and deeper down underneath the floor, down underneath the surface of the planet, you'll find millions upon millions of atmospheric pressure, not hundreds, millions, right? And even that is not enough to destroy atoms. So what would happen is all the space under compression, because people didn't understand the idea of what compression actually is, right? Compression is, it crushes space. That's all it's crushing. It just removes space. Atoms always resist. Space cannot resist pressure. Not for long, right? So the further you go down underneath the ground, you got more and more pressure, and it crushes, 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 and crushes, and eventually it turns it into plasma. Right? Like the sun is made of it, and it sends its plasma. And as you crush it and crush it and crush it down, less and less space between the atoms appear, and eventually if you go deep enough, like with the black holes get crushed to a singularity. The matter's still there, but all the energy in atoms are being crushed down to a very small, dense, little thing, right? And it's always fighting to get out. So sometimes these things blow back up, right? So compression pressure cannot crush atoms, right? What it does do is it compresses space. That's the difference. Atoms don't get crushed, they get compressed together further and further and further. That's something I really wanted to get off my chest. I don't know why, I mean I have my problems, but I think I've explained it well enough. Maybe I should do a more in-depth video with some graphics and stuff like that when I get a better computer, but other than that I just wanted to get that off my chest. Anyway, thank you for watching, goodbye for now, see you later.